Hi, this episode is an introduction to a set of episodes about Recon, or reconnaissance, within the series titled Web Application Security Testing. So I'm excited about this because this is going to show my specialization and the surface aspect of what I work in and some of the first actual finger work, you could say, or the wizardry of the character manipulation I keep talking about, and the pressing enter parts. You press enter, you hit the return, you execute, you run the command. So we'll be running some commands for the first time here. However, we're going to begin by showing you the map and by talking about what the article will be about. So there is an article that I'm going to be reading, and it's titled, as you can see here, Black Box Recon for Web Application Security Testing and Vulnerability Assessments. Actually, that's not the title. What is the actual title of the article? The title of the article here is a little bit different. It's Web AppSec Recon, Black Box Foundations and TTPs. TTP stands for Techniques, Tactics, and Procedures. We'll begin in a moment. I'm going to start with the map. And as you can see here, the headings within the article are in the green. They're theory, tactics, techniques, procedures, and after that we'll have some after Recon and endnotes with future work. So we'll start with the basic theory of Recon. As you can see here, there's going to be something about the tester, the testing model, and the target, layered pen testing, methodologies. So I'm excited about this. We're going to get into tactics, the types of Recon and sequence. Within the passive beginnings, you have the indirect, direct, and OSINT, the defensive side of OSINT and offensive OSINT. Then you get into the active types of Recon. We play with packets, you have some manual work, you have some dynamic, automated security testing, and you have enumeration. Within the techniques, you have stealth entry and observations during Recon, the context and the behavior. All these interrelate in a certain way. The procedures obviously are related with this triangle here of the passive and active Recon, and we'll show some basic examples of this. And as you can see here, this section has a special box around it. It even has a pink section, purple and a blue, and that's because this is basically the groundwork, the frontier of what it is that I do and that we can do together. As you can see here, this is where the character and signal wizardry come in. It's my specialization, and it is Recon. After this, we'll talk about vulnerabilities a little bit, and frameworks and modeling. And then the endnotes and future work is all related with the secret layer, business layer, and professional layers. And then there'll be a little mention of cloud and AI prompts at the end. So we're traveling like this through these sections. And let's get started here with the article. I'm going to be showing some links eventually. Again, this is in my Medium publication called Cyberpower Telenoia. A summary of civilian freelancer theory and TTPs, tactics, techniques, procedures for reconnaissance before the vulnerability assessment stage in a web application penetration test. Theory. The deliverable is a report. In order to improve security, we are gathering information about weaknesses in a technology that can be exploited through corresponding vulnerabilities. We use vast open source methodologies to map the attack surface. If the exploit can make a critical impact on the assets, then the risk should be mitigated and is worth reporting. The testing model. The tester performs the testing activities, tools and methodology, are the tactics, techniques, and procedures. The application, this is the target black box to test. The specialization, context plus language plus characters plus symbols, etc. There exist our computing machines, the network with its computing machines, and the target computing machines. The one who asks for a service is a client, and the one who provides a service is a server. The service itself is a web application or website. As the attacking tester, we are the client using the network of the public internet to attack and test the service on the target server. Recon can detect if the architecture or infrastructure has a weakness which makes the client side or server side vulnerable. The target computing machines. The target architecture is how it's built. Focuses on the design and conceptual aspects that shape the system's functionality and behavior, the client-server architecture, APIs, microservices, and implementation of specific security mechanisms. The target infrastructure is what it's built with. Focuses on the physical and technical elements of the IT system, the web servers, database servers, load balancers, firewalls, front-end and back-end frameworks, third-party services, and locally hosted files. Foundation, tester domain dimensions. This is a fun section to look at. I'm going to go through it in a moment. But usually in my episodes I put on my Stealth Recon mustache, and believe it or not, half of it has fallen to the floor. Let me just grab that. No, it was stuck to my chair. Okay, I got it, and I will enhance my own vulnerability right now artistically by putting myself on screen, putting the stash on in one go. There it was. Back to the article. There we go. So what I just mentioned here, and I really enjoyed making this, is you have all the words describing where exactly we are in web application security testing and how it lies in information technology, or IT, all the way down to the deliverables, which are reports. Let me read this for those tuning in audio. And visually you can see this as well. So at the beginning somewhere, this actually goes higher, but I'm going to start with information technology, IT specialist. That is the field we're in. But look at all these words that describe the precision of where we're going within IT. So we have InfoSec within IT, information security. Within that, security operations. Within that is cybersecurity. Within that is network security, or NetSec. Then in there, application security, or AppSec. I'll just stop saying in there, but every time there's a new domain, it's within the one that was previously mentioned, or as a part of the current one being mentioned. So in application security, we have secure software development, SSDLC / DevSecOps, the testing phase of CI/CD, continuous integration, continuous development. In there we have offensive aspects, and we get into offensive web application penetration testing and red teaming, which is a teamwork aspect of that. And we are working with the open source movement with OWASP, and in there we get into black box manual DAST. And then the first stage that we're working with is information gathering, or passive Recon, indirect and direct, then OSINT, offensive and defensive. We do, or we might want to, and some of us would, go stealth within this. Deeper in there, we have character / symbol / signal wizardry, and then we have electricity itself. So that we play with, and then kind of moving back but forward at the same time, we have fingerprinting and enumeration, or active Recon, so it's automated DAST scanning. And then this moves into vulnerability assessments and bug bounty hunting. And the deliverables are the reports. So let's continue here with layered penetration testing. Within popular cybersecurity frameworks which describe the progression of a cyber attack, or the equivalent professional ethical hacking methodologies, reconnaissance, or Recon, is the first stage and involves researching the potential target. It is used to identify the scope, the technologies used, and public information for building an understanding of the system. To be effective, testers should know exactly what they are looking for and how the data will be used before collection starts. Using passive reconnaissance and limiting the amount of data collected minimizes the risk of being detected by the target. Penetration testers or attackers generally follow a process of structured information gathering, moving from a broad business scope to specific data. An attacker will typically dedicate a majority of the overall work effort on Recon. Note here, there exist various levels of ethical hackers at various layers who do minimal to no Recon. I'll get back to that eventually, but it does make sense, so I'm not saying, and nobody says, that Recon is essential or necessary. But I find that there is some greater significance to it, and there's something special about it. The red team only needs specific info, not the whole range. Testers and attackers have access to current public vulnerability lists and exploitation kits. The collected information is later weaponized to facilitate exploitation. This means that a penetration tester can design specific types of attacks, exploits, and payloads that are suitable for the attack surface of the target. Methodologies. There is goal-oriented, define and work towards a goal. There's checklist-driven, the OWASP, WSTG, and Web Application Hackers Handbook. Next is intuitive. Understand the life of a web application and its context. There are more methodologies, but I just wanted to mention those because I think they define clear ones that are different enough to understand that there's different ones, a variety. Now we get into tactics, types of Recon in sequence. The usefulness of data gathered increases with the risk of detection. Passive Recon. Indirect passive Recon. In this instance, there is no interaction with the target web application or organization. Direct passive Recon involves the normal interactions that occur when an attacker expectedly interacts with the target. Defensive OSINT. To understand the current threat landscape for the target, identify any leaks, employees, and products on social media, forums, and dark web marketplaces. Other adversaries discussing the same target. Information leakage monitoring, dark web, security breaches, threat intelligence feeds, public records, indicators of compromise, IOC, geopolitical monitoring, competitor analysis. All these are part of defensive OSINT. Then there is offensive OSINT. Involves actively seeking more sensitive information that can be directly used to exploit vulnerabilities, credentials, or personal data for social engineering attacks and access. OSINT, by the way, stands for Open Source Intelligence. For the offensive side, we have scraping, social media, and Shodan, web archives, Google hacking database, etc. Next is active Recon. For example, packet information gathering, packet route tracing, the hops. Manual Recon within that involves direct queries or interactions, i.e. one particular single port test of the target network. Then there's Dynamic Application Security Test, or DAST, scanning. This is a technique that's used to discover live systems on a network, identify the open service ports on a system, vulnerabilities on host machines, and operating system architecture. More focused probing there, with fingerprinting internal and external infrastructure and hosts, port scans, listing the directories, files, and users. Enumeration. Identify the services and applications that are operational on the target system. If possible, the attacker will want to know the service type, vendor, and version. Actively probing the target system for specific details produces more useful information, but interactions with the target system may be logged, triggering alarms by protective devices such as firewalls, IDS and IPS, which is intrusion detection systems and intrusion prevention systems, and EDR systems. Social engineering. Gather information about the web application by contacting employees or vendors and tricking them into revealing sensitive information. Tactics. Recon sequence. Business logic analysis. The content valuation and application logic. Fingerprinting and enumeration. This can involve, I'll show this on the screen here, network infrastructure security, the WAF, load balancer, reverse proxy, IDPS, DHCP, the network infrastructure, such as cloud, and the content delivery network, the data center, computers, the web application server infrastructure, the operating system there, the web server there, the web application framework, the databases, resources, and dependencies there, and the domain scope, which is the IPs, certificates, subdomains, directories, file paths, files, extensions, and the spidering of these. And then there's browsing, which can be functional or explorative in the select cases, which includes access handling and input handling. I'd like to show you a different map at this point. I have another one that we'll be referring to quite often and will be enhancing over time, but it shows what was just stated here. This mapping goes like this. I'm just showing the flow visually, but I just explained here that in security operations we have the offensive black boxing, and we have the penetration testing there, of which vulnerability assessment is just a part, or you could say a stage. And in there, I'm just trying to focus this. Well, we have the listing of weaknesses and the risks and the mitigations. And then, so within that though, we have information gathering, which is the Recon phase, where we identify the scope and we're mapping the attack surface, and we use these passive and OSINT techniques, and then we get into the more, well, we can analyze business logic in a deeper way there through the explorative and functional testing, and then where we do some fingerprinting and enumeration, and then we have the active, direct, and manual DAST, and let's see here. Oh, right, and the API, the integrative aspects there, and then we get into some deeper things where we'll get into here too, but if we want to go stealth, we have to get into the VPN with the DNS, probably the open source version of these, and we get into packet design and trace routing, hopping, and then some of the first things we'll encounter as we touch our target would be a web application firewall, a load balancer, a reverse proxy, and then we get into, if we're in the cloud, increasingly so these days, we have a content delivery network with its data center, and then but however, at this point there will be some ports somewhere at the domain, the scope IP with its subdomains, and we're actually touching the application infrastructure now, or the architecture, the way how it's built, and then the actual what it's built with, and then so we'll have a specialized computer on which there's an operating system with a web server, which is separate from the web application, and the web application contains the web application framework with the tools, libraries, and security features, for example. And then in this web application, we have the directories, files, and extensions, and the databases are actually separately stored, and sort of the resources and the dependencies, and there's a caching system in between them, right? And so we're mapping all this attack surface, and we have to understand the weaknesses and the vulnerabilities and their analysis, and then we proceed into the risk assessments there, which is the likelihood and that the impact these weaknesses or vulnerabilities can make, and we review the threat model there, and then we, based on our results and calculations there of the severity ratings, for example, we can send in an encrypted report, and that is our final deliverable. But you see, I haven't even touched on all these parts beforehand there. We're going to get back to the article at the moment and continue. The techniques now. Stealth entry. To improve the effectiveness of active reconnaissance, we have stealth entry, and so and we improve the effectiveness of active reconnaissance by providing detailed information. Sorry, let me read that sentence again. To improve the effectiveness of active reconnaissance in providing detailed information. Going stealth in information security refers to the practice of conducting security testing in a covert or low-profile manner without alerting the target of the activity. That is also why I wear my mustache, so that nobody alerts any of the targets of the activity here. Attackers approach the target with a goal in mind and set the minimum number of packets needed to determine the objective. They will only test the ports that impact the kill chain they are following to their specific target, while knowing the possible maximum about the attack surface scope. First, consider securing one's own device by using a new dedicated computing machine. For example, I wrote here in italics, get a new Purism laptop for every test and have all unnecessary services and programs deactivated. That's pretty hardcore hardening there, but for some instances, for example, in wartime or in a technocracy, that might be essential. Working with evasion techniques. In the TCP/IP protocol stack, whenever a packet is sent from one device to another, the source IP address is included within the header of the packet. All address details must be included within all packets that need to traverse a network. In this way, the testing attacker's time and data stamps, the source IP address, and additional information can be identified by the target. A sock puppet. Penetration testers usually create a fake identity, a sock puppet, to mask their true identity when performing any type of information gathering. Anonymity. To remain anonymous when interacting with a web application, follow basic online OPSEC, operations security. Sock puppets on Tails OS, Tor browser with resize, NoScript, and user agent spoofing. Proxy chains, write Monero for transactions, VPS, OpenVPN, OpenDNS, MAC and IP spoofing, HTTPS obfuscation. Right, I just put up a moment of the map again here because this is what was being mentioned in this part of the visual map here, right? Going stealth. We'd probably do this on Kali or something similar. And there's the hardening there. Hardening is not a necessary part of Recon at all, but it is there. Tor is an open source implementation of free access to an anonymous proxy network. Proxy chains create a logical chain of connections between multiple proxy servers when sending traffic to a target to prevent your real IP address from being exposed to the target. Decoys. These trick the target into believing that the network scans are originating from multiple sources rather than a single source IP address. Spoofing the MAC and IP. Spoofing the MAC address simply allows the attacker to pretend to be someone else on the network, a network switch, or even a router. Ignore communications protocols. Alter the TCP/IP handshake to avoid connecting with target system and leaking data. Camouflage tool signatures, using SCAPI to craft TCP packets with specific flags set. Modify packet parameters. Randomize or spoof the source IP port, the source IP, the port, the MAC address. Adjust timing to slow the transmission of packets. Change packet size by fragmenting or appending random data. Hide within legitimate traffic. Now on to techniques, observations during Recon. What type of web app is the target? Software as a service? Or is it open source? Is it paid? Etc. First, understand the business logic there. What the app should do, what the app does, how it does this, and what can go wrong. The attack surface is all the data/signal entry points and how users interact with each other. Seek behavior associated with vulnerabilities. If the site allows or has X, then check for Y vulnerabilities. Is there any reaction to application misuse? Are there any defense mechanisms? Procedures. Basic examples of Recon. Specific tool set. The methodology, the custom OWASP WSTG. Web Application Security Testing Guide. The products, Firefox Developer Edition with any extensions, Z Attack Proxy or ZAP with any of its community extensions, and Kali Linux. Indirect passive Recon. On Kali Linux, run Harvester to collect email addresses, subdomains, IPs, and employee names from public sources. So we're going to give an example of this. Right, what I'm going to do is load these up side by side. Let's see if I can do that. I believe I can. I'm just going to load Kali side by side with the article that I'm reading there. No, that's not it. Oh no. I'm showing the the platform I'm using to record this. Oh my goodness. Okay. Wow, that did not work. Right. Well, we're going to just run these one by one. Okay. Oh, okay, just a moment here. So how did this come here? I'm just going to move this OBS back to somewhere else. Just open broadcasting software there appeared in my recording. I'm going to do this again here. We're not opening that. This is so weird. Why did it do that? Okay. So we're going to do indirect passive Recon on bitcoinsecuritymaps.com by right. I've preloaded it here. There we go. I have a command here for the terminal in Kali Linux, and I'm running Kali Linux on through VirtualBox, a hypervisor on another operating system. And I have the command here as listed in the article. I'm not going to explain this right now. I will in other episodes, but basically I'm using another operating system within my operating system, and I'm going to run a command. I've pressed enter. And now it's running the harvester, and it ran it. And it has some results there. It's showing us something very basic. Right, so we didn't touch the website. We ran a program, you could call it, some code, to gather information about the target without interacting with the target whatsoever. That is indirect passive Recon, and we completed this mission. Next we go to direct passive Recon. Right, so what I'm showing now, just to recap on this map, oh, I need to get back to this screen. Right, it's not easy running a podcast all by myself here and doing all these things. So I need to be here. I need to press map. Right. So on this map of the article, where we are is we are exploring the actual procedures of the tactics. So we're doing the passive, indirect, direct, and so on, and we're going to move into active later on. We're exploring these examples here. We are doing character signal wizardry right now. This is our specialization in Recon. Let's get back to the article with the actual example of OS within OS. So I'm not going to be over talking this much continually, but we're on to the next thing. So, all right, I have to load zap. Give me a moment here because I had loaded it previously, but what happened, and it takes 30 seconds to load, is that a fly came in the room and I basically had to chase it for at least a half an hour. I didn't actually get it. Now the reason I chased the fly was because I'm using a good microphone here, and you could definitely hear the fly in the room the whole time. I'm not sure what happened to it. It was enjoying the lights. The lights take a lot of setup. Yeah, and that took a lot of power, a lot of time, unpaid time, and so on. Anyways, so Zap is loading in the background here. It's about to show up. I need this to show you something exciting. And actually, in the meantime, I'm also going to load Firefox Developer Edition in the back there. Good, that's loaded. So I'm going to, you might see it on the screen now as I'm bringing it over there. Right, so I had this set up before the fly came in. But then I forgot to reset these two programs, but here they are. One is set, the other one is about to be. There it is. So close now. So Zap is set. I need to bring it into the screen now. So I'm using a second monitor. Yeah. And well, I'm not sure what just happened. I'm pretty sure if I had an assistant doing this, which I would gladly have. I mean, the reason is well, you know, I'd like to pay people well for assisting me, and if you offer, you know, support in the form of Satoshis or whatnot, and I gain some popularity here in doing this, I could definitely use some friends, hired friends. I wonder if I just disappeared off screen, which I didn't do intentionally. But when you move what's capturing my Sony a7 III camera, I use a special application there. If I move it off the main window, it seeks capturing it. Okay, I don't need to explain that. My goodness, yeah. Okay, where was I? There I am, and here we are. Right, Z attack proxy. I'm reading this part from the article now about direct passive recon. Configure Zap to monitor traffic from a browser while browsing the target website. Analyze the gathered HTTP responses for security misconfigurations, comments in HTML, and exposed information. So all we do is we load bitcoinsecuritymaps.com in the browser that is designated to work with. Where did it go here? Right, there it is. To work with Zap proxy. So when I type in bitcoinsecuritymaps.com here, oh no, I have it already ready there. Okay, good. And after I press enter, we'll see something appear here in this program. This is a proxy, and this is a program that's on the same computer. So a proxy here means that, well, the wizardry of the characters and the signals I am sending to the website, the target, and receiving from the target are passing through this program. Now all I'm going to do is basically browse the target as if I am a normal user, which I am a normal user, and this program will gather indirectly, or rather passively, certain information about the target website. And I'm showing it here continually because information will appear here in a moment in the white spaces. in both these white spaces on the left and in the bottom. So I'm going to get back to the Firefox Developer Edition special browser that is configured to communicate with that proxy, and we're going to press enter here on bitcoinsecuritymaps.com, and this is just some basic web page that I made for this domain. And now we should see in Zap Proxy, right, it's loaded something up here in the top left, and we're going to check out, well, we're going to check out the history here of what it did. And so it's loaded just a few things here, right? And you know, you click on these basically, and it shows you the details of the interactions between the website and my browser. And I'm going to go to alerts, which we'll have more of later on, of any particular information that might have been significant, but there wasn't any. But this is just to show you something very basic, and I'm going to leave it at this right now for you to contemplate. Let's get back to the article. I'm going to actually, yeah, okay. So, defensive OSINT. We're going to use Kali Linux now again to use Spiderfoot to search for the client's domain and email addresses on the dark web. So we're going to send a command with Spiderfoot. I'm going to clear this previous. We're going to see where I've saved Spiderfoot. Here we go. Spiderfooting bitcoinsecuritymaps.com, and I've pressed enter. So it's doing stuff. It's gathering information for us. Okay, it did some stuff. It gathered some information. That is all you need to know. Next, offensive OSINT. In Kali Linux again, we're going to scrape social media and use metagofill to extract metadata from publicly available documents that are somewhere on the website. So this is the command. I'm going to go back to the Kali Linux again. And we're going to use that metagoo. There we go. Pressing enter on this command. And by the way, like these are commands you can write things. Like I've pre-written these and saved them there in the terminal for the sake of the episode podcast recording. Pressing enter now, and it's doing stuff. Okay, it's searching for metadata in public documents on the website, which means it can gather some information there if there was any. I'm going to cancel that because it's actually doing some deep things on the internet. Next, packet information gathering. We're not going to do this because it involves a certain program that will publish some information about me here on this computer I'm using at this location. But basically you capture network traffic to and from the target web server to identify protocols, services, and potential vulnerabilities. You can filter the capture to focus on traffic related to the target. We're going to definitely do that in other episodes. We get into manual Recon now. In the specialty web browser, Firefox Dev Edition, we're going to use some F12ing there with developer tools to manually inspect the HTML, JavaScript, and network traffic. We're going to open the target website, bitcoinsecuritymaps.com, and use the inspector tab to examine the HTML and JavaScript, and then use the network tab to monitor and analyze network requests and responses. So this is pretty simple, but this is a part of actual work. So just by pressing F12 on my keyboard while here, where's my F12? Oh, I have to just put the focus into the browser there. Right. Yeah, and maybe if I do it on the actual other computer. Yeah, there we go. So the inspector tab in the dev tools shows us the website code down here, right? And you can open the indentation there and play with it, or if you want to inspect a certain part of the website, you'd go to this tool here and select the part you want to see in the code. So the visual part that you want to see in the code. You have some deeper parts of the code right here. So that is one way of just looking at, by looking at the code. People like myself who have, 25 years of experience looking at HTML, CSS, and JavaScript. Well, CSS developed later on. I actually have experience with HTML from 1993, 1994. Since then. So I can see things pretty fast. If you click on the network tab and reload the site, you'll be able to see some of the same stuff we saw in Zap proxy, Z-attack proxy earlier, and you can get into those in a different way. But this gives you some information gathering abilities also. I'm going to minimize this and back to the article. Right. Dynamic application security tests now, DAST scan in Z-attack proxy. We're going to conduct an automated scan to identify common vulnerabilities in the web application. So we're going to use the quick start tab and enter the target, bitcoinsecuritymaps.com, and review the scan results in the alerts tab. This is just a quick way of doing a DAST. This is the most basic way of doing that. So we press quick start here, and then just going to move these windows a bit. We're going to do an automated scan here. Select this. We're going to enter URL to attack is bitcoinsecuritymaps.com. And let's see, use traditional spider, yes, and we're going to attack now. So by attack, yeah, right, I just pressed enter again, right? So it's now doing a scan there in the bottom. You can see things are happening. We're going to stop this, but things are happening, and that's all you need to know. It's doing a DAST automated scan. That's how easy that was. Enumeration. On Kali Linux, we're going to enumerate directories and files on the target web server with GoBuster. Let's get in that. I'm going to clear the previous. Load up GoBuster now. GoBuster and pressing enter. There we go. What did I, there's some error. Let's see if we can track it quickly. Bitcoin, HTTPS, bitcoinsecuritymaps.com. Running GoBuster, unable to connect to. Connection reset. Okay, it's pinging Google, so I'm online and everything's working. Error on GoBuster. bitcoinsecuritymaps.com. To connect to get. That's the right IPs. Connection reset pipe here. Oh, maybe, right. It's probably something with the firewall, perhaps, which is a good sign there. Let's try it again. No, okay, well, whatever the case is, we ran the code and we'd have to work with that result. But that is what you use to gather directories and files in target web server. Next, social engineering, we're not going to do right now. But through Kali Linux, you can use Social Engineering Toolkit, or SET, to create a phishing campaign or clone a website to trick users into providing information. You can open Set, navigate through the menu to create a phishing campaign, send the phishing emails, and collect responses. And next, you can go stealth, and we'll do this as the last example here. To check if port 443, which is HTTPS, is open on a web application using the command line in Tails OS while maintaining stealth, you can use the curl command or curl command with specific options. By specifying -- resolve, you are instructing curl to directly connect to the IP address associated with blah.com on port 443 without performing DNS resolution. This will display only the HTTP status code returned. So I'll give you an example there, and it should give us status code 200 if we do this aimed at the target, which is bitcoinsecuritymaps.com as the last example here. Clear the previous and find the curl example there. There it is. Just checking it visually quickly and enter. Oh, it's not connecting anymore. Something's happened. If we do an S lookup, securitymaps.com. Right, I just did a little lookup. What? Right. Just checking the IP address that I've mentioned in the previous command. 46, yeah, 17.165.169. Okay. Well, we'd have to debug that, but where it says 000 should be 200, and that should be let's try again. 00. Okay, well, that's cool. Right, something's going on, and it's difficult because we're running an operating system within an operating system. The router here has all sorts of things on it, and we're using a IP cam app on a separate phone. Things with the router might be doing some dynamic DHCP calculations there. Okay. Just the next thing now. So after Recon, when something of interest is found, stop and begin testing. Looking for an indication of a vulnerability, for example. Unexpected message returned. Right, just like right now. Just had something unexpected happen. 000. Why? In this case, I think it's just this isn't a bug or a vulnerability here, or not a. Well, it could be a weakness in the way I've set something up, or it could be a power. Whereas the my actual hosting plan, which is somewhere, I don't own it, has something set up where if that command is run, perhaps it doesn't offer any HTTP status code. So we look for unexpected message returned, a delay in response time, unsanitized input being returned, server-side check being bypassed. Next here, testing after Recon can be performed on client or server vulnerabilities. These vulnerabilities typically exist because of a lack of skill in security in any particular stage of design, coding, configuration, or maintenance. On the server side, attackers could typically perform the following list of attacks: web application firewall evasion, injection attacks, remote code execution, file inclusion, or remote and local, directory path traversal, exploiting session management, exploiting the business logic of the system or application implementation, web services misconfiguration or excess authorization privileges, baiting the vulnerable services through shared infrastructure, identifying any relevant information that can help them to perform more dedicated attacks. Frameworks and modeling. Knowledge bases like the Mitra attack framework can be used to identify gaps in a security program and help organizations to improve their defenses against potential threats. Models like the Lockheed Martin cyber kill chain can be used to describe the different stages of a cyber attack. Here it is in 7 stages. 1. Reconnaissance. The tester gathers information about the target system and maps this attack surface to vulnerabilities, which themselves include the following testing: config and deployment management testing, identity management testing, authentication testing, authorization testing, session management testing, input validation testing, error handling, cryptography, business logic testing, client-side testing. 2 is weaponization. 3 is delivery. 4 is exploitation. 5 is installation. 6 is command and control. 7 is actions on objectives. And finally now, we have endnotes and future work. These are all professional layer and specialization layer notes. To continue this Recon exploration, please see the ASPI Hackers Bug Whisperers Discord server. And I'm just going to briefly show this again. We have this in other episodes. I have a Discord server. Everyone's welcome to it. There's a link in the article and other articles on this server. We have various channels, and There's a section here with the heading Hacking. It has 8 channels, and these describe the process with which you can join and collaborate with others on exactly what it is we're doing today, which is Recon, and moving forward. In the intro section, for example, if I click on this, it will load, well, I guess I can do it again here. It loads the Google Doc for that channel. It's usually 1 or 2 pages. So 1 or 2 pages times 8 is 16 pages maximum-ish. And so that's pretty quick. One can do that in an hour in terms of reading and just getting into making money together, collaborating. What that is exactly, we'll get into in other things. But so I just showed the example of Ethical Hackers ASPI Bug Whisperer single-page summary. It's a Google document available on the mentioned server as a link. There are many other available documents there for collaboration on paid work and deeper technical procedural insights. New cloud services are significantly impacting web application security testing, and we will adapt to these changes by integrating new tools and methodologies suitable for cloud environments. The high-level business layer would be using top technologies outside of the available public models. The secret layer would include aspects beyond popular contemporary science, such as metaphysics and psychic phenomena. It is at least worth noting their existence because they ultimately impact everything we do at the Recon specialization layer. This article was categorized as Recon, InfoSec, Web App Security, Bug Bounty, and Stealth on Medium. Thanks for tuning in. I hope this episode clarified a little bit about what it is we do with Recon in web application security testing and vulnerability assessments. We covered a bit of theory, tactics, techniques, procedures, and what we will be doing afterwards. If you enjoy this podcast and this kind of information, feel free to offer support and have a look at bitcoinsecuritymaps.com. I'll be updating the website. Use the NOSTR protocol, and my public key is available to find me and perhaps the podcast itself in the future. And Fountain.fm is a wonderful platform and has an app and for listening to podcasts and streaming Satoshis, so Bitcoin bits, so money for my remuneration for my time spent on this project and developing further line of work with Bitcoin Security Maps. For now, I will see you at the meetups.